Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm very excited today to be recording live from the Wings Conference in Portland, Oregon. We have a real audience with real live people here. This is your cue. Yeah. It's gotta be. There we go. Thank you for being here. My name is Dylan Garrett. So in addition to being a podcast host, I'm a hardware engineer, and I've spent my career helping companies build and design innovative hardware products and bring them from early stage concept to reality to commercial launch. I'm really excited to have guests from two companies today. We have Powin and ESS, both deploying battery energy storage systems on the grid, both based in Oregon. From Powin, we have Mike Wietecki, SVP of Strategy and Regulatory Affairs. And from ESS, we have John Thomas, VP of Product Management and Strategy. So energy storage is a really exciting sector of the power industry right now with huge growth projections. We're projected to double capacity in the US this year in 2024 by adding about 15 gigawatts of storage in just 1 year. It's also a really important topic to climate change. As we transition the grid to renewables, energy storage will help us level out the intermittency of wind and solar. It will also help us match supply to the variability on the demand side. That's only getting worse as we electrify end uses like our homes with heat pumps. So we'll cover that stuff in our chat. We'll also talk about industry trends, and then we'll leave time for Q&A with all of you afterwards. I'll quickly introduce these guys before we start. So Mike has a legal and finance background in renewable energy prior to Powin. He's had COO and general counsel positions and has worked with companies ranging from startups to multi-billion-dollar multinationals. He joined Powin 8 years ago as the first hire of the CEO at the time. That was back in the early startup days of the company and also the really early startup days of the industry. John has spent most of his career in automotive at GM and Ford, and then Tesla, where he was employee number one on the Model S, and he led that design team and launched that product, which I think a lot of us will remember was the highest rated vehicle by Consumer Reports ever. He has since been in leadership roles, including founder and CEO of companies in automotive electrification, energy storage, and distributed renewables. He joined ESS about 7 months ago. Both Mike and John are super passionate and knowledgeable about this space, so I think we're really in for a treat. We had a really fun prep call. I will say I was a little disappointed. We found nothing that these two disagreed on. So one of my goals today is to find something that they can't agree on. So we'll see if we can make that happen. Mike and John, it's an honor to have you on the show. Thanks for being here.
Thank you. It's
Thank
great
you.
to be here.
Pleasure.
So I wanted to start just by kind of setting the stage with a quick overview of each company. Mike, let's start with you.
Sure.
Give us a summary of what Powin does, please.
Yeah. Powin is a utility scale battery energy storage manufacturer. It's a bit of a mouthful, but we build large scale batteries, essentially power plants, out of lithium iron phosphate cells. We turn what we consider near commodity cells that are sourced from the global supply chain into highly sophisticated, highly engineered power plants that have a duration ideally between 2 and 8 hours. And we'll talk a lot about duration hopefully today, because I think that's something that does distinguish ESS and Powin, and it helps understand the market. But right now, Powin has about 18 gigawatt hours of operating or contracted or in construction projects. So our current pipeline is about 18 gigawatt hours. Our first commercial deployment was commissioned in 2017. And I mean, if you know anything about sort of scale, like when you go from your first, and it was a 9 megawatt hour facility in 2017 to now 18 gigawatt hours, that's an incredibly rapid ramp. And so happy to talk about all of the lessons that we've learned in ramping at that rate, and the industry has learned at ramping at that rate, because we're not unique in the industry. We are riding the wave. So yeah, really happy to be here. Thanks, Dylan.
John, how about ESS?
All right. Hopefully, some of you know about ESS. We're headquartered down in Wilsonville. We make iron flow batteries. This is a completely different kind of battery than the cell-based lithium-ion batteries that we know and love from laptop devices, Tesla vehicles, and then into grid scale. We also are solving for utility scale solutions. And we too have multiple gigawatt hour project announcements, and everything is kind of in framework agreements where you start at a modest initial deployment and then scale up through the years. And what we're learning is we also have observations about what it takes to scale. And you think 170,000 square foot building would be ample for a certain market need, but because of the significant shift to electrification, it's, as I said, Jaws, we're going to need a bigger boat. So it's a really exciting time to be at the inflection point of the industry.
Great. So boats deploying batteries to store energy on the grid, different chemistries targeted at different durations. I think it's maybe helpful to say you're also not kind of scrappy startups, right? I was looking on.
Yeah, not anymore.
Exactly. Yeah, not anymore. Exactly. Yeah. On the brink of 300 employees. Again, we have a very significant factory in Wilsonville that we just keep expanding and altering and adding new power lines to be able to feed the machine that builds the machine. So again, Portland General is very pleased to be spinning the meter more. So, but yeah, our type of battery is super complicated, to be honest. Where a flow battery is really like an electrochemical plant that has honestly maximum complexity as it compares to like solid state lithium ion batteries. And so it's taken decades to get to where we are. NASA started this exploration of this kind of battery in the 1970s, and they had some technical hurdles they couldn't overcome. And amazingly, the two co-founders were the team that did overcome those hurdles as it ties to what we call electrolyte health. And it's kind of separating the hydrogen that's formed during this electrochemical process. And kind of the one point where we might elbow each other a little bit is as it pertains to degradation. That's one of the reasons I joined the company. I'm a big believer in long duration energy storage as the next frontier in the solution to decarbonize the planet. And lithium ion seems to have like a natural economic and technical limit at about 8 hours of storage. And our world is, according to Department of Energy descriptions, is like 8 to 50 hours, how they describe LDES, long duration energy storage. And our electrolyte has essentially no degradation. It's really just magical, simple iron sticking to a plate, iron coming off of the plate, and repeat and recycle just essentially forever. So it's a 25-year battery, and nothing in lithium land can even conceive of that kind of life due to just the electrochemical reactions that happen inside those cells. And I'll pause there.
Yeah, I mean, the name of the podcast is important to remember, Hardware to Save the Planet. And I think there's a commonality of goals when you're looking at this type of technology. And that's to allow for, in your opening comments too, to allow for the electrification of the grid. But electrification of the grid can happen in a couple ways. One is a high carbon intensive. We all know that we cannot do that. And so we're going to need to rely on intermittent sources of generation. Renewables are intermittent by definition, to electrify a grid that is going to double or triple in demand between now and 2050. And so we have to remove all of the carbon generation from the grid, or by some estimates, 85% of all existing carbon generation. And that remaining 15% needs to have sequestration attached to it. That's a huge ask. But then you couple that with, as we electrify and as our demand grows naturally, we need to double or triple the capacity of that grid. You have to stop and pause and say, oh my God, like, how do we do that? Well, we're doing it today. There's a lot of different things you need to do, like transmission is a big part of it, and we're not doing enough of that. Generation is a big part of it. We're not doing enough of that. But storage is a brand new critical component on the grid that did not exist. It did not exist at any sort of scale 10 years ago. 10 years ago, it was science fiction. You'd go to these battery energy storage conferences, and it was literally like people showing you pictures of their garage and their battery system in their garage and the BMS that they'd hacked together. Like, we're now at a scale where Powin is building 1 gigawatt 2+ gigawatt hour plant in Australia to replace a coal-fired power plant. We're building a plant for an unnamed utility in the US that is going to replace a coal-fired power plant that just hit the ground. So we are taking off that capacity today. And the market that we're talking about, this duration market, is really important to understand. And where we've started in the industry early on was these shorter durations, because duration is equal to, when you think about a curve, sort of, and I'm using my hands. I know it's a podcast, but there's people here, so I'm going to use my hands. If you think about a day, like we have different energy demands and different generation demands throughout that day. What we started by doing is picking the generation that had to cover the top of the peak of the top day of the year and saying, how do we pull the dirtiest diesel-fired generator that's operating in a low-end community in South LA? And I mean, that's actually what did happen. And how do we replace that with something sustainable, something clean? Well, batteries were able to step into the fray and say, okay, I only need to operate this battery a couple days a year for a couple hours a day. That was an easy thing to do because that battery could be maintained and worked on for 350 days of the year and only operate for 15-ish. Well, we've moved from that to saying, and built markets around a 4-hour duration window in California. And that 4-hour duration window sort of spread globally. And lithium ion is ideally situated for that 4-hour duration window. Well, as lithium ion starts to address that peak and flatten the top of the peak and bring the bottom, the trough of the curve up, you start to extend the duration window that you want to look at. And that's where other technologies come into play. So lithium ion based energy storage has trillions of dollars of investment left in it and terawatt hours of capacity that needs to be deployed. We don't have the mining for it. We don't have the production for it. We don't have the shipping for it. We don't have the sites for it, but we're going to do it. And as we tackle that 4-hour duration, we're going to start looking, we as a market are going to start looking for longer duration projects. So the curve that we're talking about, Powin is at 9 gigawatt hours of operating, 18 in our pipeline. We've deployed 0.5 terawatt hours of capacity over the last 6-ish years. There's lessons to be learned from lithium ion that are going to be deployed in longer duration energy storage that hopefully discussions like this, hardware to save a planet, let's work together and figure it out. So happy to go there too, John, because we were talking earlier about the problems that he was experiencing in their commercial scale, and it's stuff that we've lived. We're all learning this. It's fun.
Yeah, it's funny to build on that. Again, we had an unnamed customer in just a couple days ago, and they were lamenting that they were really impressed for the first time in the history of our industry, working with U.S. Department of Energy, techno-economic modelers, et cetera. We're actually building out a 25-year total cost of ownership model to help utility buyers understand, don't judge us against lithium ion on day one installed cost. It's kind of an unfair comparison because we do cost more per kilowatt hour. But to the augmentation needed in lithium ion, and there's various studies now finally coming in with real live data reports from utilities who bought them 5 and 7 years ago. And then we're comparing our expected life of our, we'll call it mundane balance of plant components like heaters and valves and pumps. We're able to finally get a comparison to say, look, when you look at it on that scale, we actually have a great story to tell and we make financial sense. And it really had them sit up in their chair and realize. And then he kind of patted me on the head and said, well, son, 25 years is nice, but you're talking to a power guy. I need 45 years of grid-hardened, confirmed capability, and it's no battery industry is at that level. And so you're going to have to think of how many replacements or augmentations throughout a lifetime.
Yeah, we're sort of picking off these different durations, not just for operation, but for life cycle. And what do you do at the end of life? Well, there's a challenge that we'll figure out. But you touched on use case, and I think use case is a great topic to explore. And when we're talking about use case, it comes down to levelized cost of energy. And our business is really levelized cost of storage. How do you buy the most storage to fit the use case for the lowest cost? And that's what's dictating everything right now. I mean, a speaker earlier today that compared wind on the Pacific coast to coal. Well, storage plus solar in almost any sunny location is cheaper than baseload coal. And so there's an economic, not just a climate imperative, there's also an economic incentive to convert to these types of hybrid power plants because they're cheaper. We just have to build them incredibly fast in order to meet our target. And we're not going to meet our targets. It's not being negative. There's no way we're going to accomplish our targets that the state or the nation has set out because you don't have the transmission, we don't have the manufacturing capacity, but that doesn't mean it's not a great target to go after.
If you don't mind, could I bring up one point that you reminded me of this point? So in the early days of Tesla, I was actually employee 93 at the company, and there was a time when Tesla had to beg for money in its Series C and Series D rounds, et cetera. And Martin Eberhard was the CEO, co-founder, and I went on a few road shows with him. And he had this data point that he tried to really just cause the audience to change thinking and have them understand the gravity of what we're on the brink of. And he said, the data is enough solar energy reaches the Earth's surface in 1 hour to power the planet for a year. And it's like, pause, drop the mic. And so what we were talking about is that intermittency is as that curve flattens and the hours of duration to capture the intermittency where wind hands off to solar, handing back off to wind, it's kind of now becoming a triple hump day of generation, but it's literally infinite and it's free. And so that's why we have to just really impress that upon the very practical utility leaders and buying sources. And we had another different unnamed customer that was blown away with the fact that we could actually be storage on a seasonal level, because this entity just wanted to turn his dials to make level base load all year and not have to deal with the excess load at one part of the year or the excess supply at the other. And I kind of put myself in like the shoes of the operator, so I'm kind of having fun at the company, saying it's basically like Homer Simpson eating donuts at the power plant. We just don't ask him to do anything, and he's a happy camper. And this guy was like the living manifestation of that. And so he's saying, are you telling me you can be a source and a load? And we're like, yes. And he's like, wow, let's now go to the next level. And that's where we're truly modeling to understand it can be generation and T&D deferral, which saves multi-hundred millions of dollars. So it's, like you said, becoming an economically intelligent decision, not just a tree hugger kind of solution.
Right. I'd like to unpack that a little more. Like, it's clear why it's a good business decision. You're buying really cheap energy and selling it for more expensive, right? Why is that so important in the context of climate change? Why is this intermittency? Can you help us tie that back to like emissions reduction, enablement of clean energy? Because it feels like there are other ways we could tackle this potentially. Maybe you overbuild so that we always have plenty of capacity on the grid, that kind of thing. Why is this the right solution?
You know what's funny is I was at the EPRI conference in Charlotte a couple of years, and I presented in a session, and it was stunning that they were making the point that we actually don't need more generation capacity. It's just that one worst day you're talking about. So the average capacity utilization in the U.S. of grid scale electricity is like 33%. The whole 100% exists for that one awful day in August when everybody comes home. I came from Austin, Texas, 108 degrees for real, and people cranking up their AC, and then all of a sudden all the peaker plants have to turn on all the maximum generation possible. And so if you can provide a way where that's not necessary, they can defer asset investment. And frankly, they even admitted the transmission constraint is real from a really unexpected perspective, just the easements in the planning to put the actual the power lines in locations and expand the footprint. It's really cumbersome process that can be 4 years easily. And kind of a little local touch point, prior to joining ESS, I was a consultant to Daimler and Green Lane, helping them set up their hydrogen and electric truck stops. And just one truck stop alone along the I-5 that is being envisioned could have a 60 megawatt load at a peak time when trucks come in to get their electric recharge. And for those who may not understand the gravity of that number, one Walmart superstore uses 1 megawatt. So this is 60 Walmart mega stores worth of electricity all on one site. And it's like, so how do you get that distribution to that site? And the answer is you can't. And so you've got to have storage at the site. And again, with NextEra, they want to buy 100% green electricity for the whole brand for Greenlane. So
Yeah, there's no one solution. And so if we think about batteries, like how does it fit into the next generation grid and the upgrades necessary? Yeah, you absolutely need more transmission. You need upgraded transmission. Like we need better, more efficient conductors. We need rebuilt substations. But if you have a highway that has a capacity factor of 30%, and for an hour a day, I mean, I-5 Rose Corridor, for an hour a day, you need 3 or 4 more lanes. You're not going to make the billions of dollars of investment to add those lanes, or at least you shouldn't. You should make the investment in how do you efficiently use the asset you have while upgrading it. And batteries allow for that. Like batteries are the upgrade. And it's not just batteries, it's just storage. Like finding a way to save those electrons when they're generated cheaply rather than, I mean, it's not just generated cheaply. Like we're curtailing generation. Like on the sunniest days of the year, on the windiest days of the year, we're shutting down solar and we're shutting down wind. That is an inefficient market.
That's no good. Yeah.
That's not good. And then on the days where your hottest day in August, like you're paying, or the utility is paying $1,400 a kilowatt hour. So you have this massive arbitrage opportunity. And if not only can you build the assets on the grid that can leverage that arbitrage opportunity, if you can build a market that allows for you to really attack that opportunity. Like there's not a hedge fund out here that wouldn't look at a negative spread where you're paying to generate versus a $1,400 an hour cost to consume load and say, where can I invest to take advantage of that spread?
Yeah.
We just don't have the technology deployed well enough, nor the market built to allow for that.
You talked about all the scaling we need to do and how challenging that is. I was wondering if we could get into that a little bit more. Like, what are some of the big challenges to scaling this industry?
Wow. I just got to sigh. So the scale, and that's all in context also of what is happening right now in the political sphere. This industry, lithium ion cells have been developed for decades. Like you remember the first cells, I fondly look back, the little gray camcorder batteries that would click into the back of the camcorder and they're sort of ovoid shaped. And like we've had those for decades. That technology has been evolving from billions of dollars of investment to something now that's powering a Model S or powering a power plant. We didn't get to the scale we are today in a couple of years. We got to the scale we are today in decades. And we are going to grow that or expand that rate of growth even faster because we have to. And so how do you do that? Well, the biggest thing is investment. And the biggest thing is just like looking at where can you effectively build processing. Well, let's talk about the scale and the needs. There's not enough mining. There's not enough extraction to allow for lithium extraction anywhere in the world. We don't have enough lithium capacity. We don't have the processing plant capacity to process that. We don't have the transportation that is specialized to move batteries around the planet. We haven't localized any of this. Like we are scaling in China, we're scaling in Malaysia. That is starting to change in response to the IRA, but the rate of change just needs a tremendous amount more investment, both public and private, and opening up sort of the permitting and regulatory process to allow for that investment to really happen. In terms of deployment, like we're seeing years-long queues to put new assets on the grid. That's really unforgivable. When you have an asset that is both a load and generating source, that asset should be allowed on the grid without really any oversight because you can tune that asset for the capacity of the interconnect. And it's a little techie, but we don't need to think about batteries as threatening the stability of the grid. Batteries are what enable the stability of the grid and the capacity of the grid to increase without laying trillions of dollars of copper back into the ground in the US.
Why is it years?
Why is it years?
Yeah. What's the delay? The queue. This is permitting we're talking?
Yeah. So this is interconnection is the process. I mean, if you want to hop in, but interconnection is the process by which a developer of a energy facility needs to go to the grid operator and say, hey, I want to put this asset on the grid. Let me. And if I can't do it now, tell me what I need to do to put it on the grid. Well, there are a tremendous number of applications out there. And so that's a delay. You just have a ton of demand for review. So we need more people reviewing these applications. We also need to rethink the application process and the thresholds for allowing assets onto the grid.
And kind of in an ironic way, a circle back to the title of this panel, Hardware to Save a Planet, it becomes a virtuous self-reinforcing circle on hardware. Like part of the interconnection agreement that everyone is in line for is because the substations don't have the capacity. Substations can't increase the capacity because they need utility scale transformers. There's not enough transformer supply on the planet Earth. And so not only do we have to increase the whole mining through lithium ion cell supply chain capabilities and efficiency and recycling and extraction from discarded devices, et cetera, we also have to understand the kind of the mundane but very essential components of the grid that allow for more power to be transacted. And I call them the Godzilla transformers. These things are the size of homes when you get into like the 300 megawatt units, if you will. It's funny. I watch all kinds of kind of geeky YouTube movies and just to get familiar with products and competitors and things in the world. And I think it was Siemens had like a documentary of the transformer plant they were doing in India and how proud they were. And again, just enormous plates of steel that have to be laminated to make, a transformer do its thing. And it's a very special grade of steel. They actually call it electrical steel. Surprise. And I looked at that and I said, we could do that in America. We used to have enormous steel manufacturing capabilities. And when we redirected the automotive industry to be part of the war machine, the War Powers Act, in World War II to save the planet, essentially, it showed that a government and private industry can collectively achieve a mutual objective that's good for everybody involved. And so I think the IRA is a great step in that direction. But yeah, we need to 10 or 100x that level of money.
Let's talk about the IRA for a minute. How is that impacting the industry? What are the big pieces of that are either accelerating? Are there things that should be done more through that? What does that look like for you guys?
I saw a really cool graph, and I wish I could pull it up, but it showed the size of the energy storage industry immediately before the IRA was passed and then immediately after. And it basically doubled because you just made the cost of the product 30% cheaper. So you took that levelized cost of storage and dropped it by a gross 30%. Well, the applicable use cases that became economic doubled. So, that to me is the most clear benefit of the IRA is you just took the market, and a market that had already reached escape velocity. That's something that's really important to understand is the energy storage industry did not need the IRA. Some people don't want the IRA. It just makes it challenging to do business when you've got regulatory structures sort of dictating how you do things. But it had reached escape velocity. And then all of a sudden you said, okay, you're at escape velocity and everything is 30% cheaper, go. And start building it in the US. Yes, let's do that. It will not happen immediately, but it is happening. I think the biggest challenge today is really understanding what build it in the US means. It's been well over a year since the act was passed. It's been, I think, about a year since the first set of guidance, and we still are unclear exactly what domestic content, and we can get really geeky here if anybody wants to, what it means to actually be a US manufactured product. So we need guidance. We need a rule.
Yeah, it's funny that I completely agree. And it's just amazing to see the sausage making, from the absolute ignition point to, oh my gosh, it had to percolate and become statute and legislation and regulation from the U.S. Treasury through the IRS so that people actually could monetize and execute on all of the promise that was shown there. It's kind of funny. There's an automotive corollary. They call it the American Automobile Labeling Act, AALA. And when NAFTA formed and we were trying to be a little bit protectionist of our automobile industry against the rest of the world, you had to report quarterly on exactly the origin of the parts that you were buying and then, calculate percentage, and you're either in a good bucket or a naughty bucket. And you would think they could just reuse that type of methodology because it's instituted in multi-trillion-dollar industry, automotive globally.
Great.
All right, let's do
it.
Are there any big headwinds? It sounds like IRA has been a huge boost.
Boy, there are not real headwinds because there's no feasible alternative today. Not to say in 10 years there won't be, but there's no feasible alternative today to battery energy storage to even get close to our targets. And coupled with the fact that lithium iron phosphate specifically, which is chemistry we use, plus whatever generation source you've got is cheaper than what is currently operating. That just provides it's all tailwind. I think the biggest headwind continues to be education, permitting, just getting the slower to evolve utilities on board with the idea that this is part of their asset mix and it just embrace it. So education. Yeah.
Yeah, to all the stakeholders, like including government regulatory bodies and then ultimately the buyers of our technologies, because there's all kinds of LDES counsel and all these wonderful documentation sources educating at a general level, there's not yet firm established market mechanisms for in our universe of long duration from 8 to 20 or 8 to 50 hour. And so people are talking about it, but they're kind of waiting for when it becomes legislated and mandated, then they finally, I want to say have excuse, but they have a framework in which to act on it and kind of defend their decisions. So a lot of the buyers and regulated entities just have to have those structures. And so it seems like they're really warming up to the industry. They see the intuitive value of doing all the things we're talking about just because it's get out of jail free card. Like, oh my gosh, you mean I don't need to put up a new plant? I can pause that peaker and redirect those funds over to storage. Heck yeah. Then I don't have to run new lines or do anything and all the easements. So it's a win for everybody, but they're still kind of needing from FERC level to DOE to state level legislation, et cetera. And I don't know what sets the pace of that activity, but there certainly can be lobbying to impede certain things. Because I thought FERC 2222 would be the cat's meow, the whole country would go, Shazam, we're going electric and storage. And this was a mandate that FERC-controlled entities had to demonstrate a plan, I think, by 2019, and then they delayed it 2 years to say, explain how you're going to incorporate renewable energy and storage on your grid and allow for two-way power flow to take place. And a lot of folks really waited to the last hour and then tried to lobby to kick the can down the road again, and they succeeded a little bit. And then they started playing games with how they complied. And there's some cases in Minnesota that are kind of the example of good intentions not being realized within certain regulatory structures where somebody gamed it versus actually acting on at a 300 megawatt level. So it was disappointing.
You brought up a really good point, John, about market. And I think market is underappreciated driver of deployment. California had CAISO created like basically a tradable 4-hour block where you could be paid, a generator, an owner of a battery asset could be paid for just being available to dispatch to the grid for 4 hours. And what that did is created a incentive that reduced the risk to that battery operator and reduced the risk to the grid operator because they had a firm, certain source of energy for these 4-hour blocks. And again, we talked about like that demand curve and peaker plants. Well, if they know that there's going to be these blocks of 4 hours of energy available, then they can look to all of these other generation sources and say, you can go offline or you have to go offline. We don't need you anymore. We're not going to pay for you. We need those market mechanisms to be expanded dramatically. The reason why California's been so successful is because they did that. They said, here, you're going to get paid for just being available for 4 hours for a few days of the year. And it makes economic sense. It is much cheaper to do that because the battery doesn't just operate for those 4 hours. It'll operate based on whatever the market signals are. It'll play that arbitrage market. And so the battery comes online for this very straightforward and market mechanism and then assumes a role of stabilizing out the grid. And we need to do that across all grid operators. Like it's just, you have to give the market signals, you have to give longer duration market signals and create pay structures that reduce the risk to the developers and incentivize the technology to come online. And it's not a subsidy. Like it actually makes our power cheaper. And I don't know if everybody's seen, if you're in PGE territory, like our rates went way up. Well, that's because we've sold all of our energy to a bunch of data farms. Well, we're going to need to do something to counteract that because we don't have the capacity anymore in our market to meet the demand. You don't do it by building more generation. You do it by operating the grid more efficiently.
So we're here in Oregon. There's been a lot of passion and discussion today about kind of supporting this broader climate tech industry here. Why is Oregon the right place for your companies to be? And is there anything that could change to make it a better place to run your businesses?
All right. I'm a relative newcomer to the community. Again, moved from Austin, and people got to tell me about the 5 months of rain. And then they made fun of me because I actually use an umbrella. And they said, "Oh, John, you just revealed you're not a Portland native." And I'm like, "I'm sorry, it's functional." But anyway, I worked for Tesla in Silicon Valley, and then we actually had a secret skunk works we set up in Michigan. And I was really pleasantly surprised coming in here, kind of working with what I regarded as the best of the best in my career. And I helped set up Electric Neo Company in China and Shanghai, and worked in Spain and Germany, at some really neat places, and saw Stanford, MIT, all these incredible graduates doing just world-class work and thought leadership. And then I came here and I couldn't believe it. I see 20-something engineers talking about their process capability and their sample size and whether it's a valid conclusion. And I'm like, where is this coming from? I was so impressed with the caliber of engineers. And we have young people that are electrochemist, PhD, and postdoc. And I'm like, are you kidding? This is just such a surprise in such an effective way. And like you say, they just kind of organic recruitment, friends recommend friends, when it's the company has like a DNA and a culture that they feel they can stand behind. I do notice just cost of living differences, actually positive direction from kind of highly inflationary Austin and Texas, because it's growing by leaps and bounds because it's a 0% tax state. And so it's just drawing all this stuff, but it has ramifications that ripple through the whole economy and other industries that don't benefit from those incentives and things like that. And again, kind of coming from the Detroit area, it was the auto capital of the world was its claim for 100 years. And you just see how when you seed with a few of those important seeds to grow long-term significant oak trees, for example, it just naturally cascades and you get the tiers of suppliers that serve that industry. And again, I was pleasantly surprised when I got here. I didn't know Vestas had the kind of presence they had. I didn't know what capabilities Intel had on power electronics and stuff like that. And it was just like, wow, this is really impressive. Let's magnify it.
Yeah, I've actually given that question some thought because it's a bit counterintuitive. The Oregon and Portland specifically are not all that friendly to business. It's not going out any sort of limb. But what's interesting about that is you have a handful of very good larger companies that are here. And then there's a need for, well, coupled with a lot of smart people that move here for a lot of different reasons. I mean, the lifestyle is great. It's a great place to live. But smart people move here and they have to figure out what to actually do to afford that lifestyle. And so there's a risk tolerance here that I think is unique, maybe in the nation, because you're just attracting people to a location. And then there's a lower threshold of fear in starting something new. And that new seems to always be on the cutting edge. And energy storage specifically has been on and will continue to be on the cutting edge of the grid transition. And so it doesn't take a lot of smart people working together and saying, hey, what's next? What can we invest in? Here's a great idea and here's some backing. Go to build an ecosystem. And it's crazy. I mean, John said it. It's really interesting to think that you've got a handful. And to say a handful, that's actually a lot of battery energy storage companies in the Portland region. And Powin, I think it's sort of a source of pride. We're seeing spin-outs happen. And those organic spin-outs just sort of then build a more robust ecosystem and allow for more innovation. And it becomes a really virtuous cycle. So, I mean, we need to figure out how to embrace that and really invest in that virtuous cycle because companies like ESS, companies like Powin are unique. Like our capabilities are unique globally.
We have some time to open it up for questions. We got a mic here if anyone wants to jump in.
Hi, my name's Ben. And I'm just curious about, because I know that there are a number of different technologies within the LDES space. You've got the batteries, you've got the compressed air, you've got the gravity, all these different kinds of solutions. And it seems like there's an understanding that we need a lot of them to work in order to save the planet. Do you feel like that results in a different level of interaction among what might more typically be competitors?
Well, let me start. And then, so it's a great question. First of all, the pie is enormous. And so the opportunity today, if there's a technology that's deployable at scale at a reasonable cost, is going to be deployed. But when you're talking about like compressed air or pumped hydro or pushing concrete blocks up a hill on a train, those are all great ideas. Like they're fantastic ideas. The efficiency is pretty poor. Pumped hydro is still the largest source of energy storage on the planet, but the efficiency is poor and they're geographically limited. Batteries can be deployed actually where they need to be deployed. You can put a battery, and not you could, we will put a battery on every single substation in this country. That is going to happen because it has to happen. Because all the things John talked about, like you can defer a tremendous amount of investment and enhance the grid by putting a battery there. And it doesn't have to be a Powin battery, it doesn't have to be an ESS battery. Damn it, we just have to do it. So yeah, there's a big pie. It should be a Powin battery, but
depending on how long you want it to last. Right. But no, I think, there is a recognition that the pie is big enough for everyone. And we're starting to see even just a warm embrace of the utility industry. They don't want a singular solution, and they're asking for help. Like, can we form a hybrid system, have different chemistries of batteries, and I can't say a whole lot about our customer in Eastern Germany, but it was publicly announced, LEAG, and that they are doing exactly that. I would say, to my knowledge, it's the largest scale on Earth so far of a hybrid battery arrangement. I mean, whole buildings of different chemistries for purposeful, different reasons. And we're all going to be blending through the same inverters, the same grid connection point on a very grand scale, like 500 megawatts all combined. It's exciting. We're just a piece of that. And that's only phase one. They have 2 other phases behind it. And again, as a consultant, I worked with DOE a little bit on a solar pumped hydro, a little kooky idea in southern Pennsylvania where they go with rock quarries, go to the lakes, just pump it up the hill and then let it fall down and repeat. And then their cool shtick, if you will, is they got the rights. There's former Pentagon people that founded this company that they got the right of way in the center of interstate highways to run their new power lines. And we're going, ooh, this is a really good solution. So I've seen a report that said there's enough small scale water reservoirs on the planet Earth that could be ideal and be an absolute economically justifiable element of the total solution. So I think it will be a composite solution on a planetary level.
Anybody else?
You mentioned spinouts as sort of a consequence of these industries growing in Portland. I'm wondering if you could also talk about follow-on industries or supporting industries like you've seen come to Portland because of Intel, whether it's chemical suppliers or equipment manufacturers. What do you envision ESS and other battery manufacturers in Portland bringing to the Northwest?
Yeah, that's a big question. It depends on a lot of things. It depends on where we want to invest. Where does the region want to put its dollars? Does it want to put its dollars into attracting sort of the innovation, or do we want to put our dollars in attracting the manufacturing? I think that you can have sort of have your cake and eat it too, where you can build clean manufacturing, sustainable manufacturing that's going to support this industry. Like, I mean, looking at Pavlo, who's sitting here, I can't remember how many thousands of units we're deploying on a single site. It's thousands and thousands of units, and these things are massive. They're heavy steel. There's all kinds of electronic components. Like, just attracting the manufacturing of our product would be a boon to the state. But then you have the inverters, you've got transformers. There's the entire ecosystem of grid components that are not made anywhere in the US. We could do it here. Yeah.
No, I think, kind of building on that, there is a shortage. The lead time for a new deployment of any significant electrical project can be easily like 18 to 36 months, just waiting, believe it or not, on switchgear, breakers, transformers, et cetera. And so we need to, again, just double domestic supply of these things. And I think there's very solid money that can be made in those industries. And why not do it with the next gen technology so that you obsolete all your competitors? Go to silicon carbide devices and stuff beyond that. So I think, yeah, it's like University of Wisconsin is thought of as a power electronics superpower, if you will. Lots of great, just concentration of curriculum and renowned professors, et cetera, spawning these people to try to make industry in the Midwest. And frankly, it's not taking root. They're just, Hitachi and others are coming there, and I don't know if it's too cold or what, but they just don't, it doesn't grow like an entire ecosystem that should be growing. So that's a big need. And just kind of in a funny, ironic thing, just our phase 1 deployment in our German project, our partner on the project did the math, and we would exhaust the tank supply of all of Germany with just that one first deployment. They're like, oh my God, we're going to have to build more tank manufacturing. So it's kind of a good problem to have, because now they can put former coal miners who are now displaced into work into some very cool industries, and they can be proud when they come home for the work they're doing.
Let's do one more quick question, and then I'm going to wrap us up.
Great discussion. So I know with these battery technologies, there's the sort of sustainable selling points, namely that there's the use of earth abundant metals to be able to actually realize long duration energy storage. But I'm curious, what are some of the more unsustainable components of the technologies? And do you envision future generations of the technology that addresses those unsustainable components?
Yeah, it's a great question. We are deploying massive scale of equipment that does not have, admittedly, very long life cycle. Like these are 20-year, 25-year assets. And at the 20th, 25th year, something has to be done with them. The positive about that is, well, these are modular. Like these are highly modular units. It's not like there's a lot of concrete that's going into it. It's steel, it's copper, it's the cells. And there are so many cells that are being put into the market right now that, and the cells are the most difficult thing to recycle at this point and reuse, because of we have not developed a end of life supply chain to repurpose those cells yet, because it's still cheaper to extract. That is starting to change. Like there are technologies out there that are able to reprocess cells, and depending on the market price of lithium carbonate, the reprocessing can be more economical than extractive lithium sources. So like we're getting there. We're not there yet, but the industry, thankfully, is different than, this is a new industrial revolution where people are actually planning for end of life as not end of life. Like this is just part of the life cycle. And that's a novel development in the industrialized world. So it's a great question.
Yeah, and to build on that, I'd say, and it is actually happening. It was just talk. Even in the first days of Tesla, everyone, well, what about the batteries when they die? And we'd pay no attention to the man behind the curtain, and so, but to his credit, J.B. Straubel, my colleague at the time, he broke away from Tesla and founded Redwood, and he's doing fabulous stuff there and getting almost $1 billion in venture capital, if not already there, because he recognized there's not enough lithium on Earth to meet all the demand of automotive, let alone grid. And so that's just an absolute necessary life cycle circular argument there. And then on our side, that's partially the origin story. We just wanted to leverage earth abundant. Iron, sodium chloride, salt, potassium, we're good. It's everywhere earth abundant. But there are balance of system components that are still thermoset plastics. PVC is not necessarily an easy to recycle thing, especially if you glue a bunch of joints and all that. But so I can say we are looking at improved materials that give us even higher performance capabilities while also having a better pathway to end of life and reuse.
We're just seeing with some genuine batteries that they're coming to end of life, where the market and the industry is still so young that a lot of the batteries just are not at end of life yet. And as we rapidly accelerate towards batteries coming offline and needing to be recycled, I think you're going to see that part of the industry.
Yeah.
The previous question, people are going to step into the space because they have to.
Because
there's going to be so much money to be made
good
there,
point.
right? And let's be honest, that's what drives a lot of industry.
Mm-hmm.
Yeah. Just one quick point to amplify that, if it's all right. again, in a previous company, when I was in China, we were looking at a giant British consortium company that happened to own all the platinum, or the majority platinum and palladium mines on Earth. And they were seriously concerned about becoming a dinosaur and obsolete because, of all things, they're going to sell less catalytic converter material as cars electrify. So just imagine the game theory on that. So they were actively looking to invest in a green space to replace that lost revenue stream. It's like, wow, that's some great thinking.
Nick, can I have one more minute?
Sure.
Okay. Awesome discussion. Great questions. Thank you, everybody. Okay. 3 questions we ask every guest. First, how optimistic or pessimistic are you about the future of the planet and why? John.
Optimistic. As I've worked around the world, I've gotten to observe firsthand that at our core, human beings seem to have more in common than is acknowledged. And people want a planet for their children and grandchildren to inherit. So I think the majority of people will ultimately vote and act and purchase responsibly to make that a positive outcome.
Love it. Mike?
I'm massively optimistic.
All right.
I'm an optimist by heart. And I think that we are building the systems today that are a solution. And we're going to continue to. Like, we're problem solvers. That's what humanity does. Problem has to get pretty big before you recognize it. And we're solving it.
Yeah.
We don't have a choice either. So
who's another individual or company doing something to address climate change that's inspiring you? Mike, why don't you go?
Oh, I think there's a whole group, and it's the folks that are doing the really hard work of tracking carbon and emissions and just sort of doing all of the work behind the scenes of figuring out, are we actually a net positive or negative as an industry, not just energy storage, but generally, and building out the systems in order to track footprints of GHG equivalents.
I'm going to say, as an organization or entity, the Department of Energy, I think the unsung heroes, to be honest. I mean, I've never, last 14 years of my career, been working with them on the funding side, the ATVM loan at Tesla that we got for the Model S, all the way through recent work and just being reminded that it is such a national resource that they do primary research unlike any place I've seen on Earth. And it's like, and it's all free. We can literally just use it and capitalize on it. And so I just tip my hat to NREL folks and the labs all over. They're just great.
Nice. Those are 2 new ones in 51 episodes. Those are new. I love it.
All right.
Nice work.
Wow. All right.
And you didn't agree. They were different.
Yeah.
Right?
I agree with him, though. That's great.
Oh.
DOE is awesome.
What advice do you have for someone not working in climate today who wants to do something to help?
Even though I love selling energy storage, conservation is actually the cheapest kilowatt hour is the one not consumed. So we all can do our part while we're waiting for this massive grid renewable energy to be built out. And if we can just throttle down a little bit, the whole planet benefits.
Yeah, choices. I was going to say, all of our choices add up. So just making the right choices and being considerate in decision making. Alando, it was great.
Yeah.
It's sort of like he is the result of a lot of choices that people have made. We don't have to make those choices.
Awesome. Guys, that was really fun. I learned a lot. Thank you very much.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.